let's take a look at this worksheet. I know you guys are struggling with it a little bit. This is Projectile Motion, and it goes through a couple different versions of how to solve some stuff. But basically, it's just like everything else. Okay, if there's motion in X, you got to deal with it in X. If there's motion in Y, you got to deal with it in Y. If there's motions in both directions, then you've got to separate them and deal with them individually. Okay, so it says in an attempt to make a field goal, a football player kicks the football from ground level so that it has an initial velocity of 25 meters per second at an angle of 35 degrees above the horizontal. The crossbar of the goal is 40 meters away and 3 meters high. The question we need to answer is, does the kicker make the field goal? Okay, so let me set up the problem a little bit. We have a velocity for the football, and it's kicked to the right. Well, I don't know that. I'm just making that up, I guess. But it says 35 degrees, okay, above horizontal at 25 meters per second. Okay, that's what it says. Okay, so our job is to figure out does it make the goal. Okay, so what information is given for the horizontal direction? Consider initial position, initial velocity, final velocity, acceleration, and time. Alright, so let's just start with that. Initial position, x naught. We're in horizontal, so we're dealing with x. We don't really know. We don't really care. We know we could call it 0 meters. It's got to get 40 meters in order to get to the goal. Okay. Final position. So I'm going to say x equals 40, but I got to remember that doesn't actually mean the ball has to land at 40. We're trying to get it there. So I'm going to put a little question mark next to that. Initial velocity. The initial velocity in the x direction is given by the bottom of this triangle down here. Okay, so it's not 25 meters per second. It's 25 cosine 35. Okay, and we'll get a numerical value for that in a minute. Let's see. Acceleration. Well, what would cause an acceleration in x? There's no forces, so there is no acceleration. Time. We don't know time. Okay. We know it moves through the air, but we don't know anything else. Alright, so now we need our numerical value for initial velocity in x. For that I'm going to use a calculator, and I want to show you, make sure you're doing things right. I think you guys all know how to do this. But when you use your calculator, depending on how it works, sometimes you got to put it in backwards, right? 35 is cosine times 25 is 20.5 essentially. Okay. So this is 20.5 meters per second. All right, that's what we know in x. Okay, what do we know in y? Well, v naught in y, or I guess I should start that over. Position everything, right? So initial position in y, and since this is in a different direction, I'm going to use a different color. Okay, initial position in y is 0 because it was kicked from ground level. Initial velocity in y is equal to this side of this triangle, so that's 25 sine 35. Okay. Final position. Again, it said the goal is 3 meters high. That doesn't mean the ball has to be there, but we're hoping it is. Okay, so I'm going to put that. Final velocity, don't know it. Acceleration in y, well, that's gravity, so negative 9.8 because it's pulling down meters per second. And I do not know a time in this direction either. Okay, and so what's 25 sine 35? If we take a look, 35 sine 25, and we got, whoa, that was not what I had in mind. 35 sine times 25, 14.34. Alright. Okay, so this I'm going to write that 14.3 meters per second. Alright, so now I have x and y separated, and our job is to figure out how does it go. So this is going to walk us through one way we could do this. First it's going to say, how long does it take us the ball to travel to the goal? Well, we know it's got to go 40 meters. I know a change in position. In order to get to the goal, right, a horizontal distance, ball starts here, goal's over here, this distance is 40 meters. Okay, so the change in position is 40 meters. I know a velocity in x was 20.5 meters per second. I should have changed back to blue, right? Because now all of a sudden I'm in the horizontal direction. So let's go ahead and do that. Alright. and then let's see, acceleration in x is 0, time I don't know but I want to know. So second equation is change in position equals 1/2 at squared plus v naught t. Well, when the acceleration is 0, what I can do is I can just say 40 meters equals 20.5 times t, divide both sides by 20.5, divide by 20.5, and let's see, 1.95 seconds. Okay, so t equals 1.95 seconds. 1.95 seconds after being kicked, the ball ends up traveling that far. Okay, so does it clear the goal? Well, let's figure out how high it is. So now we're switching back into the y direction. Okay, so my initial position is 0. My time, it takes 1.95 seconds to get there, so I want to know where this thing is at 1.95 seconds later. Acceleration in y is negative 9.8, and initial velocity in y was 14.3 meters per second. Okay, so then it's the same equation. Change in y equals 1/2 at squared plus v naught t plus y naught. Okay, but now everything's in the y direction. So let's see, and I guess the change in y not, whatever. Okay, so this equals negative 4.9 times 1.95 squared plus 14.3 times 1.95. Doesn't want me to write over there. That's sad. Okay, 1.95. Imagine you see it. Alright, so then I can do this. 4.9 times 1.95 squared, 1.95 squared, times 4.9 negative equals negative 18.63 plus 14.3 times 1.95, close that parenthesis, equals 9.25. Alright, so that gets me a distance of 9.25 meters high. Okay, so does it clear the goal? Well, the goal was only 3 meters. Okay, so yeah, yes, it does. Okay, by how much? By about 6.5 meters or so, 6.25 meters. So yeah, that's one way to do it. So what we did there was we figured out how long does it take to travel the distance in x and figure out where it is in y, and if it clears the goal, we're good to go. Okay, this is the exact same problem, but now we're going to work it another way. Okay, it says using the information from before, not all that stuff we calculated later, what can we say, how can we do this another way? And so the other way is to work in the y direction first, right? And so we still have the same problem. Ball's here, goal's over here, this is 3 meters. The ball's got to go up and come back down, right? And so we could figure out how long it takes the ball to get to 3 meters, but since it passes 3 meters in one direction, it'll pass it again. So there's going to be two answers to this problem. Okay, so our v naught in y is our 14.3 meters per second. Okay, our acceleration in y is negative 9.8 meters per second. Our time is what we're looking for. There's going to be two answers. And let's see, our initial position in y is 0. Our final position in y is 3 meters because we want to know when does it actually get to 3 meters. Okay, so what we're going to have is y equals 1/2 at squared plus v naught t plus y naught. Okay, and so I'm going to have 3 equals negative 4.9 t squared plus 14.3 t plus 0, it starts on the ground. Subtract that 3 over and I get 0 equals negative 4.9 t squared plus 14.3 t minus 3. Okay, this is a quadratic equation. There's no getting around it. Now, if your calculator has a solver, awesome. If it doesn't, it should. Okay, let's see. Mine doesn't, so I've got to remember the quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so let's see. Let me work this out real quick. Alright, so after I work that out, I get 0.22 and 2.7 seconds. Okay, which of these is the answer to the question? Well, probably T2 because the first one is on the way back up and it's barely moved at all. Second one's on the way back down. Okay, the other time, okay, so the other time that's way up, right? Cool. How far will the ball travel horizontally during this time? Well, we know the initial velocity in x. In fact, the entire velocity in x is, 20.5 meters per second? Okay, so if we take our 20.5, we're just doing this equation again, x equals 1/2 at squared plus v naught t, but there is no acceleration, so it's just v naught times t, 2.7. We get that the ball travels man, can't make my calculator work. 55.35 meters. Does it cross the crossbar? Well, how far did it have to go in order to cross the crossbar? It only had to go 40 meters. So yeah, totally crosses. Yes. How do I know based on this answer? Because at 40 meters, the ball was high enough, was above 3. Okay, so there's two ways to do the same problem. It was just working x first or working y first. It doesn't really matter. Okay, this is a very similar problem. It says a hot air balloon is rising at a constant rate of 3 meters per second at an angle of 70 degrees above horizontal. Okay, so down here I'm actually going to draw that. This thing is moving up and right like this. This angle right here is 70 degrees. Okay, and I'm going to erase that, but because I want to draw it a little bit less steep so that we can see what's actually going on. Okay, all right. So it's going to have components just like everything else. Okay, it's going to have an x component and a y component. This is 3 meters per second, and we're supposed to figure out. And the balloon starts 150 meters in the air. Alright, we're supposed to figure out the horizontal component of velocity the instant this sandbag is released. Well, the sandbag's moving with the balloon, so it's just this side of this triangle, so that's 3 times the cosine of 70. So 3 cosine 70 is equal to, should be pretty close to 3, or not 3, to 0. So 1.026. 1.03 meters per second. Alright, the vertical component of velocity, well, that's this side of the triangle, right? So that's just 3 sine 70, and this one should be fairly close to 3 because that angle is pretty steep. So 3 sine 70 is 2.82 meters per second. Okay, maximum height of the sandbag above the ground. There's a variety of ways to go about doing this. Okay, you could go to the third equation or the second equation and the first equation. Okay, but the key to doing this is that its maximum height, its final velocity is 0. Its initial velocity is not 0. Its initial velocity, okay, and we're talking height, is the 2.82 meters per second, right? This is all in the y direction because we're talking how high it is, not how far it's moved horizontally. Acceleration in y is negative 9.8, and we want to change in position, really. We want to change in y. So change in y equals 1/2, or not. We could do 1/2 at squared, but then we'd need the time, and so that doesn't work for me. So instead, what I'm going to do is I'm going to say, okay, final velocity squared equals initial velocity squared plus twice the acceleration times the change in position. This will let me calculate it because I know 0, I know 2.82, I know plus 2 times negative 9.8, and that'll let me find delta y. Okay, so 2.82 squared divided by 19.6 is 0.41. Okay, so my change in position is 0.41 meters, which is not the answer to my question. It said what's its maximum height above the ground. Since the whole thing started 150 meters high, it's 150.41. Kind of ran out of room there. Meters. How long does it take for the sandbag to reach its maximum height? Alright, this is a really simple question. V equals 0, V naught equals 2.82, acceleration equals negative 9.8, and we're just supposed to find time? Okay, V equals V naught plus AT. So 0 equals 2.82 plus negative 9.8 times time, and so if we take 2.82 divided by 9.8, we get 0.29 seconds. T equals 0.2877. 0.2877 seconds. Okay. You could use the second equation and the quadratic and do all that, but golly, why? How far above the ground is the sandbag 5 seconds after being released? This is still in the y direction. V naught in the y direction was 2.82. V, we don't know. we know a time. We know a time is 5 seconds. We know an acceleration is negative 9.8. We know our starting position was 150 meters, and all we want is our final. So second equation works spectacularly for this. Y equals 1/2 at squared plus v naught t plus y naught. So we're going to have y equals negative 4.9 times 25, that's 5 squared, plus 2.82 times 5 plus 150. And if we work that out on the calculator, because who wants to do that math in their head, we'll see that the sandbag is wow, I must have goofed that up. Oh, I totally did. I have like 1,000 meters and it should not be that high. Okay, 41.6. Y equals 41.6 meters above the ground. So it's fallen a long ways down. How long does it take for the sandbag to reach the ground after being released? This problem is deceptive. Okay, you cannot say the final velocity is 0. It is moving when it hits the ground. All you can say for sure is the final position is 0. Okay, initial position was 150 meters up. Initial velocity was 2.82. Acceleration was negative 9.8. And we can find the time. It's the second equation again. Y equals 1/2 at squared plus v naught t plus y naught. Okay, so 0 equals negative 4.9 t squared plus 2.82 t plus 150. And again, it's a quadratic equation, right? So go ahead and run that through on your calculator, however you solve that. A is negative 4.9 because it's got the negative. B is 2.82 and C is 150. And from there we'll see 2 times. We don't need a negative time, we want a positive time. So T equals 5.83 seconds. Now that's kind of an impressive number when you think about it, because at 5 seconds it was about 42 meters high. At 5.83 seconds it's on the ground. That means it fell that last 41.6 meters in 5.83 seconds. G, what is the horizontal component of the velocity of the sandbag just before it hits the ground? Well, now this is an easy question. Okay, we know our initial velocity in x. We calculated it up here. And since there's no acceleration in x, it's still the same exact thing. So 1.03 meters per second. What is the vertical component of the velocity just before it's the ground? Well, v equals v naught plus at, and so we have v equals 2.82 times, plus negative 9.8 times 5.83. Okay, so negative 9.8 times 5.83 plus 2.82 times, now what about this, where did this 5.83 come from? Came from there, right? So it's going 54 meters per second, but it's negative. Negative 54.3 meters per second. It should be negative, it is falling down. Alright. Magnitude and direction of the velocity of the sandbag just before it hits the ground. Okay, so this is actually says put these vectors back together. It's moving this way at 1.03 meters per second. It's moving down at 54.3 meters per second. And what it wants is this side. Okay, how do I find that side? Pythagorean theorem. 1.03 squared plus 54.3 squared raised to the 0.5 power, take the square root, is essentially 54.31, right? That doesn't surprise us. It's mostly moving down. So 54.31 meters per second. Now what about a direction? How do I get that angle? Well, it's the tangent, but it's the arctangent, right? So tangent to the negative 1 of opposite 54.3 over adjacent 1.03. And that angle is going to be almost 90, 88.9 degrees. Okay, so at 88.9 degrees below horizontal. Okay, so that problem, again, you're just breaking it up into x and y.